Hi, this is Ben Finio with Let's Go Boys and Girls, and this video is an introduction to our Electronic Textiles project, or E-Textiles for short, the third and final project in our electronics course.
The main idea behind E-Textiles is that instead of using regular wires, you can use special electrically conductive thread to weave electrical circuits directly into fabric and clothing. So you can see what I have here is a sewing needle, a spool of regular sewing thread, and then a spool of special electrically conductive thread that's actually made out of fine strands of metal wire. I also have a battery pack and a bag of special LEDs that are designed to easily be sewn into clothing. So you might not be able to tell by looking at these at first that they are LEDs, because if you remember the Squishy Circuits project, you were dealing with LEDs that are much larger like this, but clearly if you look at this shape, it would be kind of awkward and difficult to mount this directly onto, say, a t-shirt. So these LEDs have two little holes and two pads on them that let you sew them onto the surface of a piece of clothing and then use the conductive thread to make a circuit and connect them to the battery pack. Now here I have a somewhat large, bulky AA battery pack. This can be a little more cumbersome to use with E-Textiles, but since it's much cheaper, it's what we have included in this project to start. These are only about $1.50 each, and while they do make battery packs that hold coin cell batteries, the same kind of batteries you would find in watches or other small electronic devices that are very flat and much smaller and easier to use with E-Textiles. These are also much more expensive at about, I think, $8 or $9 a piece once you throw the battery in. So to keep costs down, we're going with the AA battery packs, which are a little bulkier but will certainly still work fine once you attach them into your clothing. Now, unlike the Squishy Circuits project, with E-Textiles, you need to plan your circuits out in advance because they're much harder to undo and fix mistakes, since you're making somewhat permanent attachments by sewing things into fabric, and then you'll have to cut the thread and start over if you want to fix something, as opposed to just squishing and pulling apart Play-Doh, which is much easier to do. So, what we'll recommend doing is have each student bring in their own article of clothing to work with, an old t-shirt or hat or glove or something. Keep in mind that larger things like t-shirts will take much more time depending on how proficient students are at sewing, and just due to the distance of thread they'll have to add as opposed to something smaller like a hat or a glove. And remind the students that they should remember the difference between series and parallel circuits from the Squishy Circuits portion of the course. And the same principle applies here. You're just hooking up LEDs to a battery, and fundamentally it's no different. In this case, you're using conductive thread and these tiny little LEDs instead of the big ones. In the Squishy Circuits, you were using Play-Doh and big LEDs, but the circuit is still the same concept. You need to hook the LEDs up to the battery pack in parallel. So I'm just going to sketch out a simple example of a t-shirt here, and you will have to pardon my poor artistic skills as I draw my outline of a t-shirt. And let's say that I have 4 blue LEDs and I just want to put them in a line across the front of the t-shirt, which is easy enough to do, no fancy pattern. And I want to tuck my battery pack down kind of by the waistband so it isn't awkwardly hanging up by the collar or the sleeve or something. So my battery pack's down here. And I know that my battery pack has a positive and a negative wire. I'm going to color code these with black for negative and red for positive. And I also know that each LED has a positive and a negative terminal. So again, I'm going to color code those with little red plus marks and black minus marks. So I know that to connect these in parallel, I need to connect each negative LED terminal down to the negative wire from the battery pack, and I need to connect each positive one to the red wire from the battery pack. But I need to do that without crisscrossing my conductive thread traces on the surface of the shirt, or that will create a short circuit, which will prevent the LEDs from lighting up. Again, your students should remember about short circuits from the Squishy Circuits portion of the course. So in this case, it's easy enough to see that all I need to do is go directly up to each LED from the negative wire and then hook around the top to the positive part of each LED from the positive wire, and I can easily do that without crossing these wires and creating a short circuit. But for example, it wouldn't be acceptable to route a red wire like that because then I'd have a short circuit right there where it crosses over the black one. So this is easy enough to do for this example where I have 4 LEDs just in a row, but if your students want to have the LEDs in a more complicated shape, or if they want to put them, say, some on the sleeves and some on the back of the shirt, then they're going to need to take a little more time and effort to figure this out and physically lay out the circuit traces where the thread's going to go before they actually start building. So encourage your students to do this and make sure that they have a plan before they start, because if they don't, it can waste quite a bit of time if you start sewing a trace and then realize it's in the wrong place. The next thing you'll want to have your students do after they have drawn out their circuit diagrams is to attach their LEDs to the fabric using regular non-conductive thread. So I just have 2 LEDs I'm going to use as an example here, and I am actually not very good at sewing, so apologies to anybody watching this who is skilled at sewing and knows what they're doing, because I'm probably butchering the process here. But I just use these 2 holes in the LED. You can see that this LED comes on a little board. This clear rectangle in the middle here is the LED itself, and then the board includes a built-in resistor to prevent the LED from burning out. We discussed this in the Squishy Circuits project, how if you hook an LED directly up to a battery without a resistor, or in the case of that project, the Play-Doh, which provides some resistance, the LED will burn out. So these LED boards include a little resistor to prevent that from happening. And then there are 2 holes on either side which are coated in metal, so they're electrically conductive. That's what allows you to electrically connect to the LED, but it also lets you just have a little loop to use regular thread to sew the LED down to the surface. So I am going to fast forward the video here so you don't have to watch me spend the next 15 minutes sewing this on, but the idea is that you should have the students line these up and pay attention to the polarity of the LEDs. These are marked. They might be kind of difficult to see in the video with tiny plus and minus signs, so they need to pay attention to the direction and make sure they don't get these flipped around to make sure it coincides with what they did in their circuit diagram, so it will work when they come and start putting in their conductive thread. Okay, now that that's complete, you can see that I have my 2 LEDs sewn directly into the surface of the shirt, and the next step is going to be to come in with the sewing needle and the special conductive thread and trace out the circuit that I outlined earlier by connecting the positive terminals of the LEDs and the negative terminals of the 2 LEDs, and then bringing those 2 traces down here to the corner where I'm eventually going to install the battery pack. So now you can see that I have my first trace almost complete. I'm going from the positive terminal of this LED to the positive terminal of the next one, and then started my way down towards the corner of the shirt. And what I want to do now is sew this needle directly onto the positive terminal from the battery pack. And instead of just tying them together, I'm actually going to strip a little bit of extra insulation off the edge of this wire using my wire strippers. So there I have a nice long section of wire. I'm going to lay that flat on the shirt and then sew the conductive thread directly to this so I don't have this wire dangling off to the side. And now I have the red wire from the battery pack sewn into the shirt here. I could probably add a little extra non-conductive thread to help sew this down back on the insulated part to make sure that it doesn't get tugged out up here from the metal part, but I haven't done that yet. My next step is going to be to come in and add the negative trace to go to the negative wire from the battery pack. Okay, so now that I've completed my sewing job, you can see I have both LEDs held down with the non-conductive black thread just to make laying the circuit out a little bit easier, and then I have the special conductive thread connecting the 2 positive terminals of the LEDs to the red wire and the 2 negative terminals to the black wire. So if I've done everything correctly and I have a good strong connection with the conductive thread, when I flip my battery pack on, both of these LEDs should light up. And you can see that at first glance it looks like I've done everything okay, and both my LEDs light up when I turn the battery pack on and off. But there are 2 things you really want to watch out for with this project, especially for people who are new to sewing, such as myself, actually. One of them is weak connections between the LEDs and the conductive thread. So you can see that it looks like I did a pretty good job with my LED over on the right here. I can move the shirt around and it doesn't go out. But the one on the left, if I scrunch the shirt up It looks like that thread is actually coming loose, so it's not making good contact with the metal pads on the LED, and that causes the LED to go dark, so I probably should have tightened that up a little bit. Maybe I can go back in and use some more thread to loop around and get a good connection. You'll want to watch out for the same thing with the wires from the battery pack and make sure you have a really good knot there. You can see that I actually didn't do a great job with my red one, and if I pull on that, it'll slide right out and cause both LEDs to go out. So you'll probably want to have the kids secure the battery pack. Exactly how they do this probably depends on what article of clothing they're wearing. For example, maybe you could tuck it into the wristband of a glove or the band of a hat or inside the waist of a t-shirt and use tape or thread to sew it into place, because you definitely don't just want the battery pack dangling, or the weight might pull these wires out. And then as a safety note, you also want to be very careful that nothing's getting hot due to a short circuit, especially if people are going to be wearing this clothing. You don't want to have hot wires touching against bare skin because somebody could get a burn. So if you feel the wires getting hot, that's a problem, and you should turn the battery pack off and double check everything for a short circuit and cut some of the wire out and re-sew if you have to. So that concludes the third and final project for our electronics course. We hope you and your students have had fun with it, and will continue to enjoy electronics in the future. Thanks.